Hello, this is the genuinely approachable Sudoku for the 9th of March 2024. It is Classish. Oh wow, it is a. Did I type that in right? A Classish Snipe by Philip Newman. I cannot say that for some reason. It is a Classish Snipe by Philip Newman. There we go. It is a thermal Sudoku. So yeah, very simple rules. Let's look at them. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits along thermometers must really increase from the bulb to the tip. So for example, thermals here must increase from the bulb to the tip. That means every digit must be greater than the previous digit, for example. And can be greater by any amount as long as it is greater than the previous digit, that is fine. Right, so those are the rules. With that, let us just begin solving. Right, let's talk about, well, pretty much the only trick with thermals that is used here. It has a very interesting little trick because we notice that these thermals are all pretty long. In fact, all thermals here are exactly 9 digits long, which tells us something. It tells us that the digits along the thermal must exactly be the digits 1 to 9, and they must be in ascending order because digits must increase, from bulb to tip. So we can do this very quickly. The first digit of all thermals must be 1, the second digit must be 2, the next digit must be 3. I don't know if this is fast if I just... Oh! Look at that, you can do that. So, nice. It will help you select the nth digit from the length, from the thermals of the same length. So that's very cool. Alright. So yeah, that is the trick they use here. It's just every thermal that is 9 cells long just contains the digits 1 to 9 in ascending order. Alright, let's continue solving. This box requires a 1 and a 9. 1 must be here, 9 must be there. And this functionally acts like a regular classic Sudoku at this point. So I guess that's why it's called a Classish Snipe. It is almost like a classic, except it starts off with some pretty fancy stuff. Okay, let's do some regular Sudoku. So 2s must be one of those cells. And 8s must be one of those cells. I believe this might be X windmill all over again. You can see every cell and its neighbor, or not neighbor, and its partner rotationally symmetrical along the grid, sum to 10. It might be, but I cannot prove it. So yeah, alright, let's keep going. This actually looks not that trivial actually. 4 in this box though must be here. That's the only place 4 can go. 3 follows to be here. Those digits have to therefore be 8 and 9. Next, I believe we can do the same thing here with 2 other digits. For example, 6s can only be here. The 7s follow to be placed here. Those digits are therefore 1 and 2 to finish the column. Those digits are therefore 8 and 9 to finish the box. This 9 here resolves that. Those digits are 1 and 2, this 1 resolves that. Okay. Got the central band complete. Let us keep going. There might be the same thing here, honestly, although I'm not entirely sure if there is. 8s? No, we did 8s. 3s? 3s are close, but not quite. 4s? No, alright. I think I'm going on a wild goose chase with numbers. Let's see, 9s. 9s in this box. This 9s mean 9 must go there. Which means what? Don't know, but I can probably do the same with 1s in the opposite corner. Yes, the 1s here force a 1 into that cell. I guess 1 is one of those 2 cells. Which might mean something in this box. In fact, yeah, where does 1 go in this row is the question. Because of these 1s, they can't go in those cells, so 1 in this row must be here. You can probably do the same with 9s in this row then. The 9s can't be in those cells, which means it must be there. And the reason why I'm jumping back and forth is because I'm suspecting the X windmill. Right now I'm not using it to solve the puzzle, but I'm suspecting it. And therefore, I look at the places that are rotationally symmetrical and see if the clues tell me the same thing in both places. They should, although I'm not entirely sure, but checking is always good. Alright, this is 2, 6, and 7 to finish the row. 2 can't be there. Those digits are, well, they are 3, 4, and 8. to finish the row, and 8 can't be there. So that's good. What else can we do? Could probably do a bunch more stuff, honestly. 3s, no, I think we did 3s just now. 9s? We have most of the 9s. Can't really tell you what else though. 4s? 4 is one of those cells. 4 is one of those 3 cells. 4 could be there, so 4 is not. No, alright. Well, that's fine. Eight in this box, there you go. The two 8s, see those cells, so 8 goes there, which resolves this 8-9 pair. This 9 does in fact force a 9 into this cell, which gives us all our 9s. 2s, I can probably do the same thing. 2s in this box must be here, which resolves this 1-2 pair. This 1 means there is no longer 1, forcing 1 up here. Yeah, there we go. The 2s... Well, the 2s are in this column, there you go. Can't be here, can't be there, can't be there, so 2 goes here in this column. The last 3 digits here are 3, 4, and 5. 3 and 4 can't be there, so that's 5. Which means this forms a 3-4 pair. Can we do the same thing here with like 8s or something? Yeah, I guess 8 in this column. Because of the 8s here and in here, I think. Or I guess more simply, the 8s here, here, and here remove 8 from those cells. Therefore, 8 must be here in this column. The last 3 digits are 5, 6, and 7. Because this digit can be 6 or 7, it is a 5. This is therefore a 6-7 pair. 4 removes 4 from that cell. And I guess 6 removes 6 from that cell. This digit actually just is something, it's a 4. So that digit would be a 6 to finish its row. I don't know why I didn't see that. But that is cool. Now what? Well, now 6s in this box are in one of those cells. And in either case, we'll look at that cell. So that cell can be a 6, that's 7. Now 7 must be one of those cells in this box. Which means in this box, the 7s actually see those cells as well. So 7 must be there. Can do the same with a bunch of stuff on the other side. For example, 4s must be one of those cells, which resolves this 3-4 pair. 3, as a result, must be one of those cells, which along with that 3 removes 3 from those cells, so 3 goes there. This 2 and this 7 form a 2-7 pair here, while this and this form a 3-8 pair, which also cannot be resolved, but we'll get to that later. This forms a triple consisting of 4, 5, and 6. This cannot be 5, that cannot be 6, this cannot be 4 or 6, so in fact it's just a 5, which resolves everything up top. Those digits are also 4, 5, and 6. This digit has to be a 5 because it can't be 4 or 6. This 4-6 pair is resolvable. That last digit there must be a 3, which resolves this stuff over here. 3 in the corner. Actually, I haven't seen 3 in the corner in a while. 8 means that's 3. 3 resolves this 3 over here, so 3 goes there. This digit is now just a 7 to finish the row. Those digits are 8 and 5 to finish the box. 8 resolves that. This is a 2-7 pair. I don't know what we're going to do with that, but that digit is therefore a 5 to finish the box and the row. That digit would just be a 7 to finish the row, which gives us everything. That's a 2, that's a 6. This 2 resolves this last 2-7 pair. Solving the puzzle in 8 minutes and 26 seconds. Alright, we took a little slow of an approach today, but I think that's okay. It's not too challenging. In fact, it's mostly classic Sudoku after getting the thermals done. So yeah, hope you enjoyed this little video. I'll see you guys next time. Bye bye.